presentation. It's a big honor for me to have the opportunity to address you all. I guess congratulations are in order to the whole department. Yeah, to achieve 80 years is quite an achievement. So congratulations to all of you who have contributed to that. And Welding Alloys is not quite that old. We're fairly old, but you guys are definitely well ahead of us. And I'd also like to say congratulations to all of the undergraduate metallurgists, because I think you've all made a very good choice in entering a field and learning a set of skills and knowledge, which I think will stand you in very good stead for the years ahead. So, I think kudos to all of you for making the right choice so far. So, great. Looks like my presentation is ready. So,
yes, sir.
If we could just move on to the next page. Okay, so in the presentation today, I'm going to talk a little bit about the Welding Alloys Group, also around wear protection fundamentals, some R&D activities for welding alloys, and the impact of coronavirus, as well as at the end some opportunities that we have for metallurgists within welding alloys on an ongoing basis, and also within the welding industry. Just to give you a little bit of background, the company was started by my dad, Dr. Jan Stekly, and I grew up very close to the factory. So every day my dad would come back from the factory, he would have lengths of wire, he would have little weld samples, and I thought this is, sorry, I haven't gone on to that yet, sorry. If you don't mind just scrolling back. How about I just tell you when to move forward? Thank you. So he would come back every day with little weld samples and lengths of wire, which I found unbelievably boring when I was a kid. So when the time came for me to decide what I wanted to do, I decided to become, I didn't want to have anything to do with the family business, and so I became a lawyer. And then after doing that for a few years, I then decided to change tack entirely and join my brother in the family business in welding alloys. And I can say actually that doing metallurgy would have certainly been a lot easier in terms of the learning curve at the beginning, because it's a very, very technical activity, what we do, and it's really rooted in metallurgy, and we'll get onto that shortly. So there's three divisions basically to welding alloys. So the first is the manufacture of welding consumables, so consumables being wire, predominantly cord wire, and also electrodes. We also manufacture equipment for wear protection, and we have a service activity where we get components into our workshop and also go on site and do welding service work. If we could move on. So we service a wide range of industries, and the advantage of being well diversified is if any particular industry is suffering a downturn, there are others which make up the slack. So certain industries at the moment, for example, oil and gas is really suffering, and so they might not be spending a lot on infrastructure, but maybe mining is, so there's always some which are going well, some which are not doing so well. And I think that's a big advantage to working in an industry which serves many other industries. Next slide, please. So that's a photo of my dad. So he originally grew up in Czechoslovakia. He was born in Czechoslovakia. They left Czechoslovakia in 1938. He grew up in Brazil. He traveled to Canada. He met my mother in Canada, moved to England, did an MSc in metallurgy at Cranfield University, and after that set up Welding Alloys Limited in Falmere, which is a small village outside of Cambridge. And then later on in life, he also did his PhD in metallurgy at Cambridge University. So metallurgy, in terms of the formulations of the products that we make, is really grounded within the company. And today we have approximately 45 metallurgists working within Welding Alloys in different fields throughout the world. We started off making FLUX initially, and then moved into making cord wire. I'm not sure if you're all familiar with cord wire, but it's basically a process where you take a steel strip, you form it into a U or a V, You put in powdered minerals or metals, close it over, and then draw it down, and then put it onto bobbins and spools and drums. And cord wire is a growing part of the welding industry because it's a lot more efficient than stick electrodes. We also then started making our own welding equipment, which we use to apply our wires. That application there that you can see in the photograph is a very early application for repairing roller idlers in earth-moving equipment undercarriage, which is still done today to some extent, but really integrating that process was one of the key drivers for the business early on. We then moved into INTEGRA, which is where we integrate our wires and machines and provide a service to the customers using Welding Alloys wire, Welding Alloys machine, and Welding Alloys personnel, and we provide the full service to the customer. We then also started manufacturing seamless flux cord wires. So instead of a mechanical closure of the steel strip, we used a laser to seal it, which obviously has some big advantages in terms of hydrogen pickup inside the welding wire. We hit a financial milestone in 2012. Today, I think we're doing about £160 million, and we offer now the largest range of products and services in the world to combat wear. Next slide, please. So I don't know how well you can all see that, but that is the map for around the world. The red marks are Welding Alloys subsidiaries, which are mostly Integra service centers, and then we also have 9 production sites, mostly geared around Europe. Probably 2/3 of our business is still coming out of Europe, but we're seeing more growth in Asia and also in South America. Our location in India is located just outside of Hyderabad, and we've been there since, I think, 2008. So we're very much invested in the Indian market. We also have a joint venture project with SAIL, and we're working in a variety of different industries in India. Next slide, please. Okay, so just to a quick overview of our welding alloys, or our welding alloys, or our consumables that we manufacture. So next slide. We have all of our own production equipment we make ourselves in France. So that's a photo of one of our newer mills on the left. And being able to manufacture our own production equipment allows us to have a tighter control over the process. We made around 11,000 tons last year, which considering a lot of them were very small batches, so we'll make 150 kilograms or 500 kilograms of a particular batch to meet exactly what the customer needs from a product standpoint. And that's something that we do that a lot of our competitors do not do. They want to manufacture hundreds of tons of the same product, otherwise it's not profitable for them. We have a very different model where we try and really understand exactly what the customer wants and make the product tailor-made to them. And then the packaging, you may have seen in your time spent in workshops, that's spools, coils, and drums of welding material. So we have a complete range of hard-facing cord wires. So we were more well known to begin with hard-facing, which is more protecting against abrasion and impact, versus cladding, which is protecting against corrosion. But we are the #1 leader around the world in hard-facing, and we manufacture a complete range of hard-facing materials. Next slide. We also focus on joining to a lesser degree, but more focused on really advanced welding consumables where there are particular applications where we know we can add certain value to a product or an application to, again, make exactly what the customer needs. So the vast majority of the welding market is in that top line there, constructional low alloy steels, which are used for construction or ships or bridges, that type of thing. There isn't a lot of really value add, and it's a very commoditized market, and we tend to stay away from those sorts of applications. Next slide, please. Yeah, so moving on to our welding equipment. Again, this is made in France. On the left here, you can see a 5-head machine, which is used for welding plates. So a steel substrate with a welded surface on the top, which provides a very high wear resistance in an abrasion type of application. We have a variety of different machines. These are all custom made for different applications. So if it's screw flights or roll cladders for the steel industry, we'll custom make a machine to meet, and that is a bit like the razor blade and the razor type of application. You sell them a machine, and then you can often sell you develop a very deep relationship with the customer, and then you end up supplying the welding consumables then thereafter. So that's kind of a nice thing of offering both machines and consumables. Aside from the portable machines, on the left we have a machine for welding a cement mill. You can see the roll of the cement mill. So we'll go on site with our teams, weld for 1 or 2 weeks to rebuild the surface of those rolls back to the original profile, using a material which will last significantly longer than the base material, which is usually a NIHARD type material. In the middle, we have a rail buggy, which is used especially for tramway type of welding and rebuilding. And on the right, we have a machine for the sugar mill in sugar industry. So that underneath there, you can see the teeth of a sugar mill roll, which is used for crushing sugarcane. That suffers from a lot of abrasion as well as corrosion. And so we have particular solutions which can be used to increase the efficiency of the sugarcane recovery. Then our INTEGRAT services. So this is where, like I mentioned before, we will use our machines and our wires to provide a complete service to the customer. And it's a big part of actually going in, understanding exactly what the customer wants, looking at the wear profile, using our experience as well. Sometimes we will redesign the geometry of certain components in order to provide longer life. And we have about 25 service centers around the world, which significantly more than we have for wire production, because it's something where you really need to be local and close to your customer and understand exactly what they need. And we go in and offer, using our metallurgical and mechanical expertise, offer something different and better than what they're used to. Next slide. A lot of the time, it's understanding the precise working conditions of that component and understanding where the wear profile is. So even though you might have two identical pieces of equipment in two different plants, the wear profile may be different. And so we'll often use 2 or 3 different types of material to weld one component. And so in the areas where you've got the most amount of wear, in the areas where we have the most amount of wear, we'll use a more high alloy, maybe more expensive type of material, but then we might get a uniform wear profile rather than a certain wear profile in one area, which causes that component to then have to be taken out of service. So we're always trying to make the whole, everything fail or everything wear out more or less at the same time, and often understanding with the customer when their maintenance shutdowns are, because sometimes a component might be lasting 1.5 years and they don't need 3 years, they only need it to last 2 years. So understanding and offering something which is efficient and just provides exactly what the customer requires. There are a vast number of different INTEGRAT applications. So we have in every single industry, there are areas wherever you've got any type of material transportation, crushing, milling, grinding, any type of material that's flowing through another component, any type of hammers or material metal to metal wear, we find wear. So one of the applications, we've obviously got some pipes, we've got a zinc galvanizing pot used in the cement plant, a sieve there which is used for sizing, probably in the sinter plant, hammers maybe in the cement industry, other applications in blast furnaces. But every single industry where there is, like I say, any of those types of processes, there are applications for us to come in, use our expertise, and make those components last longer. So really working together with our clients, we'll look at all of these types of, we want to understand exactly what type of wear the component is under. We want to know what the part's being used for, what the problems are, what the part actually is, dimensions, photographs, why the last one got worn out, where it got worn out. Sometimes there are things that the customer doesn't actually realize. They'll think there's no impact, but actually maybe the magnetic separator may not be working, and sometimes you might get tramp iron coming through different components. Really trying to understand and going in and advising the customer as a trusted advisor and going through all the details. So we're not just trying to sell them any product. We're really trying to understand deeply the application. Of course, I'm sure you're all familiar with carbon equivalent, understanding what the base metal is, and that'll help determine preheat and post-weld heat treatment required, if any, what type of procedure to use, deposits to be, to thickness of deposit, whether you can withstand cracks. All of these types of things can be very, very important in our product selection. So we kind of think of having two different families within the products that we manufacture, particularly our consumables. We have on the left impact and abrasion. We have certain products which are very good for impact resistance, like chrome manganese type steels, which are work hardening. Other materials which are very good for combined abrasion and corrosion, and then other materials which are fantastic for abrasion but really can't take any impact. And then other materials which are maybe more cost effective, which are for like tool steels or high speed steels, where you don't really need the longest life, you just need it a little bit better than the base material. And then when you think about temperature against corrosion, we also have materials which are fantastic at high temperature but not so good with corrosion, other ones which are fantastic with corrosion and high temperature, and those tend to be cobalt and nickel type materials, which are more expensive at the higher end. But we have a complete range really for any type of wear that our customers are experiencing. So we're just doing a little, I thought it'd be fun just to have a little quiz, just to for everyone to be a bit engaged. So we've got a couple of different applications here and multiple choice. I'm sure you're all very familiar being at university with multiple choice questions, but there's no polling here, so nobody's going to know if you get the right answer or not. But we have a crusher bucket on the left. So if you can imagine pieces of limestone, rock falling into there, all of those components are turning around. You can see the hard facing on the surface of them. They're turning around fairly slowly. And then a concrete jaw crusher, which is for sizing, again, for rocks, and particularly in the mining industry. So would you think that is A, high impact, high abrasion, B, low impact, high abrasion, C, high impact, low abrasion, or D, low impact, low abrasion? And the answer is... if you could, do you want to go to the next slide? Yeah, so well done to everyone who guessed A. It's a high impact, high abrasion type material. And you can see we've got, over here we've got an austenitic matrix with titanium carbides dotted in there. So the austenitic matrix provides the toughness required for good impact resistance. And then the titanium carbides are very hard, which provide the abrasion resistance. So we have a good product there, which is good for combined abrasion and impact. Next slide, please. Another application we have is in drill heads, so particularly in oil and gas. Would you think that a drill head would be high impact, high abrasion, B, low impact, high abrasion, C, high impact, low abrasion, D, low impact, low abrasion? And it is low impact, high abrasion. So here we have a product called nicarb, and you can see the microstructure is very different. We have it's a nickel matrix because we use a nickel sheath or strip. The reason why we do that is because of the toughness that we get from the nickel, but also we can weld at a much lower temperature, which means that the tungsten carbide particles do not dissolve in solution and they maintain their size, which then gives it the abrasion resistance. If you do not use a nickel strip, then you will a lot of those tungsten carbides, which are quite expensive, will dissolve into the solution, and you'll end up with a tool steel type of material instead. So that's what we use for really, really high abrasion type of applications where nothing else works. Next slide. Okay, so we've got other applications here. So hammers, you can have hammers are used in a wide range of different industries, as from metal to sugar to cement industry. There's many applications. And gears, you can see that area in the middle there where you've got some hard facing and some wear. And what type of material would you think we'd want to use there, or rather, what type of wear mechanism are we looking at here? Do you think this is high impact, high abrasion, low impact, high abrasion, high impact, low abrasion, or D, low impact, low abrasion? So make your guesses. And the answer is a high impact, low abrasion. And for that type of application, we'll use a austenitic chrome manganese steel, which is called APO. You can see the in the as welded condition is the microstructure on the top of only about 20 Rockwell C. After work hardening, it increases significantly up to 50 Rockwell C, and that is a fantastic type of material for a high impact type of application, which we'll use on hammers very successfully and gears. Thank you. A slightly different one now. So in continuous casting, you can see the obviously very hot piece of newly cast steel moving along the surface of a roll. We have water cooling going on. What would you think we would have here? Low temperature, low corrosion, low temperature, high corrosion, high temperature, medium corrosion, or high temperature, low corrosion? And it was C, high temperature, medium corrosion. And for this type of application, we'll use our 420 stainless steel, which is a martensitic structure, which is a very, very good all-round material for corrosion and also erosion at high temperatures. So if you got all four correct, you can give yourself I'll give you a virtual thumbs up. So some key R&D initiatives that we are having in the company. Some key focuses for us at the moment. If you could scroll on. Laser hard surfacing, so laser hard facing or laser cladding. We see a huge amount of opportunity with. We have some number of trials going on right now. Welding of continuous casting rolls is a very big application for welding alloys. Normally it's welded submerged arc or open arc, and we're finding very, very interesting microstructures using lasers. And so we're working with a academic partner in the UK, an industrial partner, and it's being spread out throughout the company to start offering this service to our customers. We're also working on a new solution for boiler panels. So you can see on the top picture, that's a boiler panel, and that's like a heat exchanger, particularly in power stations and also pulp and paper and steel plants. And this is a tri-metallic or tri-material process. At the base, I don't know how well you can see that, but at the base there is a bonding layer. The main part of the deposit is a highly corrosion-resistant nickel alloy, and then we have a capping layer of very abrasion-resistant ceramic at the top. And we're finding that this combination is providing us with some fantastic results in service, which is allowing us to gain, quite significant market share, because this. Sorry about that. That's my children starting to. We're starting to gain significant market share. It's a big opportunity as well with this type of application. Next slide, please. So we've been working on with machine learning. So we have a huge amount of data sets, and it was interesting just to hear you, Dr. Ghosh, talking about the data, because we have a lot of data within welding alloys that we sometimes did not know always what to do with. And when we're making a welding wire, when we're formulating a welding wire, we'll think about what types of obviously alloys to put in, and then we do a lot of G65 wear test. So G65 is the main, is the only AWS approved wear resistance test. It's a sand and rubber wheel abrasion test, and we have a lot of G65 results. We have a lot of different chemistries that we've made. So over the years, we'll experiment. Obviously, it's quite a long and painstaking process to make a new wire, develop it, formulate it, make it, draw it down, put it onto a spool, weld it, analyze it. You know, it's you don't really want to do it unless you've got some confidence that you know it's going to be something good and it's going to be something interesting. So by putting in all of those data sets that we had around the materials that we've made in the past and the G65 results that we got, we've had some very interesting suggestions or outputs from it. So some of them have been giving us some chemistries which are actually allowing us to significantly reduce the cost of the wires that we make to achieve the same type of wear resistance. And in other cases, it's a completely new type of alloy which we'd never thought about before, but provides extremely long wear resistance. So it's helped on the lifetime side and also on the product cost side. So this is another R&D project where we're basically using a twin wire process. So the first wire is welding, and that's a normal hard-facing wire, and the second wire has tungsten carbide particles inside, much larger ones than the nicarb product I was mentioning earlier, but much bigger, like very highly visible to the naked eye. So big components, and we're able to put those using a continuous process into the weld pool. So obviously the weld pool is cooled down significantly, and you can see the cross section there. It's only magnified a few times. You can see that the particles are very large and easily visible to the naked eye, and we're actually able to get significantly better results than ceramic, which were previously the best, one of the longest lasting types of solutions in one of our key industries. So we're all quite excited about this type of solution. We're also working with Cranfield University on wire arc additive manufacturing. There are some huge opportunities for cost savings for our clients. You can imagine the amount of waste if you need to make a small component and machine out, you know, the center of a pipe, and it's made out of a nickel alloy, for example. There's a huge amount of material wastage costs. So we're working to using our materials, which are designed specifically for this type of application, to then work with our clients in order to manufacture parts, a little bit like a sort of 3D printing type of application. And currently, that's just a research project at the moment. So those are some of the main R&D. There are also a ton of other wires that we're continuously developing. So we have R&D teams around the world, and they are also developing the whole time new wires and new formulations as well. But those are some key R&D initiatives that we're all quite excited about. So obviously, COVID-19, it's been quite a rough year, I think, for everybody. And I guess, I don't know when you're all graduating, but if, you know, maybe it's good timing for you or not, I'm not sure, but it'll finish at some point soon, and I'm sure we're all hoping it's much sooner than later. But going on to the impacts for welding alloys, there's two main impacts, I'd say, for welding alloys. One is that we're not able to go out and visit our customers. So or rather, we are in certain cases domestically in our own countries, but we do a lot of international sales, and we're unable to go and get on a plane and go to Madagascar or wherever it is that we know where our customers are asking us to come and visit them. So we are mitigating that to a certain degree, having as many webinars as we can with our customers, but it doesn't really replace carrying out inspections. So going into the customer's site, having a look around their boneyard, which is where they keep all their old components, and looking at which components, you know, we think we can repair, which ones we think we can be, you know, sent to our workshops. So there's a lot of things which we can't do over webinar, but we have managed to get some significant orders over webinars as well. So I think customers are starting to come around to it as well. Also for us, we've been unable to travel to carry out, particularly internationally, to carry out welding service jobs. So we've had to offer alternative solutions. In some cases, that's the customer sending us internationally their components. They're usually not very keen to do that because there's a lot of cost and customs and admin and paperwork to figure out. But they have been quite receptive as well. It has happened in some cases, but they've also been quite receptive to us offering new components which have been pre-hard-faced. The impact on our revenues so far this year is about negative 20 to 22. And from my discussions with other people in the welding industry, that's pretty much standard. So it's hard to know exactly how much of that is jobs which are going to be postponed, which we're going to end up doing in the second half of the year, and how much is a actual drop in demand. Certainly, there's an element of a drop in demand. There's been, like the German automotive industry was shut down for 2 months, so there has been a drop in demand for sure. But minus 20%, considering this is probably the worst crisis in 100 years, or maybe let's say since Second World War, I think is not too bad, and it goes to show that it's quite a resilient type of industry. So we don't go through extreme peaks and troughs. Generally speaking, when the economy is going up really, really fast, we'll sort of go up. So when it goes down a lot, we'll go down a little bit. So it's a fairly steady type of industry to be in. And like I mentioned before, having that diversification across many different industries and across many countries also helps. So trends for the future, I see a lot more in the way of working from home. I think we're all getting used to doing a lot more in the way of webinars and meetings. We have executive team meetings. We've got global meetings going on, as I'm sure you guys do in an academic environment. And we're also working out that we can do a lot of the work that we thought we needed to do face-to-face. We don't need to do face-to-face. So we have R&D people who were working who are living in the UK but working in France, and we find actually that they can do their job just as well staying in England. They don't need to be going to France in order to do their job. They can do everything online or over video, and it seems to be working out quite well. And I can imagine that becoming more of a trend for the future. So I can imagine us, right now we have IT teams, for example, in the Philippines, and I can well imagine us having, metallurgists or R&D teams in other parts of the world, maybe India, and I don't think it's necessary that people need to be all together in one location, for that to happen. I think that's going to be more and more of a trend in not just the welding industry, but in all industries. Could you have the next slide, please? Okay, so back one, last slide. So as far now, just forward one. Okay, so in terms of metallurgists in the welding industry, like I mentioned, we have quite a number working within welding alloys, and there are many working in the welding industry. The three main roles that we have today of metallurgists in welding alloys. Number one is in QC and production. So that's particularly looking at going around making sure that what we make is what we expect to make when we develop, when we make a work order and we test it, it's coming out exactly as we expect. Working with our raw material suppliers, making sure that the material that they're supplying is going to fit through our production easily, whether it's mesh size of the raw materials or every type of, or the type of steel that we have or how it's presented. There's a huge amount of detail that goes into what we make, and detail oriented people, or even OCD type people, are what seems to work best in a QC and production type of role. Then we also have a number of metallurgists working in sales. So particularly in certain industries where we have where our customers are mainly metallurgists. I'm thinking particularly in the steel industry. And when we have a metallurgist on our side that can go and really get into the details of metallurgy and talk, face to face with another metallurgist and explain the benefits of our materials from a deep perspective and answer all the questions that they might have, that really helps to get ahead. And I think metallurgists very, very quickly understand our range of products and are able to hit the ground running. I think it depends a little bit on your personality, whether you think that's something that you could do. It can also be a bit lonely being in sales. You are by yourself for a significant amount of time, and you also do get rejected a lot. It's the same as maybe applying for a lot of different jobs. You get a lot of different rejection letters, and it's the same in sales. You knock on doors and people are too busy, they don't want to see you. So you have to be quite resilient and also be obviously very outgoing and personable to be successful. And then we have research and development, and that really is looking at the trends for the future, formulations, tweaking our formulations, understanding different flux combinations with different alloys, how things are going to work best to make our products run smoother and provide longer life. And so I think that definitely suits people who are very cerebral and creative, and there are a lot of opportunities within our industry for people in all three fields, really. So I guess it's up to you all to think about what type of person you are or what type of character you are, and you need to think, okay, that's if you want to get involved in the welding industry, that's the path that I think would suit my type of personality. Okay, so I think that's come to the end of my presentation, so I'm happy to answer any questions. Thanks again to you all, and congratulations again to you all, to the department, and also to all the students that have been listening. Thank you.
Thank you, sir, for such an insightful presentation. Now, a few questions from our curious attendees. We have already asked them to put them down. Over to Ritam.
Sir, we have a few questions for you. Like the first question is, where should we focus if we are looking for a welding job industry?
Where should you focus if you're looking for a job in the welding industry?
Yes, sir.
Well, I think persistence is always works really well. I mean, if I think about myself and the people that have that I've hired, I think people who are able to come with something different to show that they're really interested in it. I love people, I love bringing people on board who are truly passionate about the welding industry. There was a guy in the US who we were interviewing him once for a production role, and we said, yeah, but do you really love welding? And he rolled up his sleeve, and he had a picture of a power source as a tattoo on his arm. So from our perspective, it's clear that this guy is really passionate about welding. And so I think people who are passionate about welding, and I guess if you want to get involved in it, show what your passion is. Show why it means something more to you than any of the other topics that you've been studying at university. Has it been a hobby of yours? Have you got relevant work experience? Why is it particularly that you want to get involved in that? And I think that can be very persuasive. You don't have to get a tattoo, though. That might be taking a bit too far.
Do you have any message for the upcoming entrepreneurs?
So go for it. If you have an idea that you think is going to be successful, I think it's a growing market. The welding market is expected to grow. Well, prior to COVID-19, it was growing about 6% a year, and I think a lot of that additional market growth was probably going to innovative new companies. So if you have something which a new idea that you have, then I think it's a fantastic to start your own business or work with somebody, come along with an idea to a business owner, and maybe they'll help fund it for you.
Okay, sir. Thank you for joining our session.
No problem. Thank you very much.
Thank you, sir, for your time and sharing with us some of your insights on the metallurgy, a role of metallurgy engineer in the in your welding alloys, and also the post-COVID-19 industrial scenario.
Thank you
And
very
thank you,
much.
sir.
Thank you. Thank
Thank
you,
you for
everyone.
joining.
Bye-bye. Bye-bye.